Now let us kick off problem one for day one. This one is called longest repeating character replacement 424 on LeetCode. It is a classic sliding window problem where we are allowed to make at most key replacements in a substring so that all the characters become the same. But before I proceed with this problem, I want you to take a look at the constraints, okay? The length of the constraints is strings can be 10 to the power 5 and as will only contain uppercase English letters, okay? Now let us move to the dashboard and we'll try to solve it. So the problem statement is as is given in this white text, and we'll start with the example. Suppose we have been given a string s a b a b, and we have been given k as 2. Okay, what does it mean? It means, hey, what is the substring of max length that we can have if we are allowed to make a switch, or if we are allowed to change any character up to 2 times? Okay, so instead of calling it k, I will call this a budget. Okay, so it tells us, hey, we haven't given a fixed budget, and using this budget, we have to generate a substring. Okay. So what is a substring? Substring is the longest contiguous characters. Okay. And it is different from subsequence because subsequence not necessarily has to be consecutive. Okay. But substring has to be. Now, what could be the brute force approach for this problem? The brute force way could be to look at every possible substring, count how many replacements we need, and see if those replacements are within the bound of the budget. Okay. For example, suppose I generated arbitrary number of a substring and I chose randomly a substring out of that, and I found out that the number of maximum replacements that we can need in that string is 1, but our budget, in this case k, is 2. So in that case, we can proceed to replace that string with the max frequency of the characters present in that substring. Okay. But generating a substring is a quadratic path, so that will take up order of n square. And as we saw earlier, the string length is 10 to the power 5, which will, exponentially increase it to 10 to the power 10, which is something we don't want. And so we will discard brute force and we'll try to solve it using optimal approach. Okay. So in this problem, one of the most optimal approach or the most favorable one is to proceed using sliding window. Okay, so sliding window is a concept in which we have 2 pointers, left and right, and we expand the right pointer, we move the right pointer. Okay, but when do we move left pointer? We move left pointer when we violate a condition. Okay, I will show you with an example. In this case, let me do a walkthrough for this case. Okay, so suppose we have AB, and we have been, our left pointer is at this part and our right pointer is at this part, and we have budget k equals to 2, which means we have a budget of 2, means we can replace any character 2 times. Now before I do a dry run, let me show you something else. Okay, and this is a very important thing. Suppose we have n number of characters in a substring, and let that be denoted by purple length. Okay, so that is the current length of our substring. But within the substring, when we investigate more, we found out that, hey, there are a common characters of yellow nature. Okay, and their frequency is this much. So out of all those purple length, yellow nature occupies up to this part, right? And the remaining part, this one, what are these? These are nothing but characters which do not resemble yellow nature. Or in other words, we can tell the characters in this region are much more like noise. Okay. Now, what do we do with those noise? We try to ask, hey, the characters which are present here and which are acting like noise, are they within our budget? Is their quantity, is their quantity within the budget? Hmm? If that is the case, then what we can do, we can convert or swap, not swap, we can replace this noise and make them yellow again. Okay, we can replace this noise and make them yellow again. Why are we able to do that? We are able to do that based on this condition. The quantity of that noise was less than k. Okay, now let us come back to this try run. Initially, what we see is our left and our right pointer both are at index 0. We will also maintain a hash set or dictionary where we will compute the maximum frequency within substring. Currently, A is 1, Now what do? We move right pointer up to this part, okay? What do we see? We see that, hey, we encountered a new character B and its frequency is also 1. But up to this case, up to right now at this point, what is the maximum length? The max length is 2, okay? Max length is 2. And what is the maximum frequency? Maximum frequency is both are 1. So in that case, maximum frequency is 1. And when we do this simple arithmetic 2 minus 1, what do we see? We see it equates to 1, which is less than the budget, okay? Budget is 2 here. In that case, what do we do? In that case, we can easily swap B and make it A. Why are we doing this? We are doing this because we succeed in this case, okay? We succeeded with this simple arithmetic, which we were asking about our budget, okay? Now, what do we do next? We move our right pointer next to A and we increment the frequency of A to 2. Again, we compute, hey, what is the maximum length up to this point? The maximum length up to this point is 3, all right? What is the maximum frequency? We come back here and we see that maximum frequency is 2, okay? And this equates to 1, which is again less than the budget. K is 2, right? So 1 is less than 2. What does it mean? It means, hey, if we have been given a string like this, A, B, A, in that case, I can replace a character. What will be the character in this case that needs to be replaced? Which is the noise? The noise is B, right? We can replace B and make it A. So the max length up to this point will be 3, okay? Now, I will again increase my R pointer and will bring back to this point, okay? In that case, B, the frequency of B will increase to 2. We'll see, hey, what is the length up to this point? The length is 4, right? So we write 4 and we say minus 2. And what do we get? We get 2, right? What do we notice? We notice, hey, this is again less than or equivalent to K, okay? So it has to be less than or equivalent to K. It means, hey, we can make a replacement. How many characters we can replace in this case? We can replace 2 characters in this case. Whichever 2 characters are acting as a noise, we can replace them. So in this case, I will replace B and I will make it as A, okay? So what will be the maximum length? So the maximum length attained will be AB, AB up to this point, okay? Let me choose a different color. It will be this point, right? AB, AB, right? And we chose B as the noise and B was replaced by A and B was replaced by A and we got a substring like A, correct? And this substring was achievable. Why? Because we were not violating this simple arithmetic which we were using to compute and to check out with budget, okay? And budget is the maximum amount of K that we can have. Now here is the basic code walkthrough. So initially what we'll do, we'll declare a simple empty dictionary and we'll declare a left pointer and we'll also declare a maximum length. That is something which we'll return towards the end, okay? Then we'll run a loop. Since we are running a loop across the length of S, across every single character, it means it will be traversing every single character, right? So the time complexity will be order of n. In the next line, what I do, in the empty dictionary, I add right pointer value at the right pointer and increment its value by 1. And then this condition is a very, very important condition because in this case, I am doing the same arithmetic check that I did above here, length minus frequency. It should be less than or equivalent to K. That is what I'm doing over here. It is a very, very, very important check on the budget that we are making. This is the length part, which was here, purple length. This is the frequency part, which is like the actual substance in our string, and we're checking what is the value of noise and if that is greater than or K or not. If the noise exceeds K, it means we can not make a replacement and we have to chop that off, right? We have to chop it off. What do we have to chop it off? We have to chop it off the noise, and the noise is getting chopped off by moving the left pointer. As you can notice here, this condition, it is pretty much different than the conditions that we checked above, right? And when this condition gets different, like when this mean condition is violated, right, we check out that we are moving the left pointer. As I told you initially, in a sliding window, we move left pointer when our condition violates, okay? So in this case, our condition is getting violated. because the noise is more than the budget and we cannot offer to have replacement. So we are moving the left pointer by 1, okay? This line, it simply checks is if the left character value at the left pointer, if its value is 0, we are simply removing it from the dictionary. But again, this is something which is not important, but we can include it still just to maintain the sanity of the dictionary, okay? And when we break out of the loop, what we do, we compare the max length and we store it in the max length. And when we exceed, when we iterate through the entire loop, what we do, we exceed, we come out of that and we return max length, okay? So this was the total walkthrough of this code. And if you talk about time complexity, it is order of n. If you talk about space complexity, where is it coming from? It is coming from this specific part where we are declaring the empty dictionary. And its order is order of 26. Why order of 26? Because as problem states, our problem will only contain uppercase English letters, okay? The string will only contain uppercase English letters. And since there are 26 of them, so it will be order of 26, which is like constant, okay? And the time complexity will be order of n. Let us move to the LeetCode board and we'll try to submit it, okay? So this is the problem. I will just paste my code. I will run it. And as you can see, it passes and it gets submitted, okay? So that was all for this problem. Now, if you want to take a look at few important things like the pitfalls that we can avoid. So one of the major pitfalls that we can avoid is that this condition, okay? We need to take a proper look at this condition. We also need to make sure that every time the condition is false, we have to increase the left pointer, and we also have to make sure that we update our max length, okay? So these are the edge cases that we need to take care of. One of the other important edge cases that the string can be empty or all the characters in the string can be same. Both of them can be taken care of by by just checking the length of the string and converting it into set if all those characters are same, right? So that was all for this problem. Let us move to problem 2 for day 1.